So hello everyone, let's start with the video. In the previous video, which is basically you're getting on the I button. So in that I have explained the same problem, which was brute force solution. So in this video I'll be solving the optimal one. And problem is police and thief. I think previous video I've seen and how did I solve, But let me try to explain you optimally how to do it. So in the previous video, one thing I stressed more was that ki the police, whatever is there at the location, right? So he will try to catch the thief which is leftmost side, right? So it was TT, PP, TP. So this is second example basically, and K given was 2, and this is our array. So basically in this problem, in this video I'll be solving the optimal solution and I'll be using 2-pointer. Why 2-pointer? I'll tell you. In the previous video I was more of stressed was on the, like, let's say this is a police. So we have a left range, we have a right range. So we will start from the left range. Whichever thief is caught, that will mark as visited in our vector, which is basically caught vector, and we were moving to the next police, and we were doing the same thing. So in this video, if you, in the previous solution, what if you had seen is that, let's say P was here and this thief was caught. So next time, since we are taking from left to right, so there will be no thief for the, let's say for this police, this thief is caught. So for the next police, there is no way any thief will be previous to this thief. Reason being, because for this police we have taken the leftmost thief. Okay, this was the actual solution. Let's say this was the actual thief. So for this police, now nowhere, let's say thief is there, means also that will not be possible. Reason being, distance. So we have taken distance from till at most k distance, right? So if we're let's say it was a distance k, so now we are moving to the right side, one distance is increased, and when we try to find the thief from this particular location to the again left hand side, again distance will be more. So distance will be, let's say, k plus 2. So which is not asking the question. In the question that we asked, distance has to be lesser than equals to k. Our distance, this has to be lesser than equals to k. I think you got what I'm trying to say. So basically what I'm trying to say is that we will keep 2-pointer. One will be pointing at P, which is police. One will be pointing at T, which is from left to right, will be leftmost side. So now we have a 1-pointer. Now we'll try to take a distance. These are basically the indices. So distance will be 2 minus 0, which is 2, and it is less than or equals to k. K is basically 2. So which is true that so if it is a true, which means this particular police can catch this thief. So we will move to the next pointer. We will move to the next pointer. So we have came here. Now again same thing we'll do, like our pointer will be pointing to the next police, and one more pointer will be pointing to the next thief. So let me name the pointer so it will be easy. Pointer P, police pointer, I'll be naming a small p, and I'll be naming pointer T with small t. So basically this is the scenario right now. Now we have got a police, this police have got a thief. Now we will move this pointer next to T, and this pointer will be moving to P. So in this case, hopefully both P pointer is pointing to police only, T pointer is pointing to thief only. Again we'll find the distance, which will be 3 minus 1, which is 2, and that is less than equals to k is fine. So again this police will catch this thief. So we'll move the next pointer to T, we'll move the P pointer to P. So in this case, if you see this is a thief pointer, but it is pointing to police. So our pointer will move. Again, this is pointing to police. Our pointer will move. Again, this is a correct pointer right now because thief is pointing to thief only. But this pointer, police is pointing to thief, which is wrong. So we will move the next pointer P. Right. So now in this case, if it's the distance, that will be 5 minus 4, which is 1, which is less than or equals to 2, is true. So again, this police will catch this thief. So basically, all the thieves will be caught. So I think what I'm trying to say, you're getting. So whenever we have a pointers which are in the range, now let me take one example. Let's say we have a police, police, thief, thief, thief. Okay. So let's say this is the example, and k value given is 1. So our pointer will be pointing to here. Police pointer to police, thief pointer to thief. But if you see in this case, this is a thief and pointer, and its distance is 0, 1, 2, 3, 4, 5. So it is like 2 minus 0, which is 2, and which is less than equals to k is false because k is 1. 2 less than equals to 1 is false. So this is not a valid right now. So in this case, if the distance is not valid, so we will check if thief pointer is left side or right side. If thief point, I mean whichever pointer is left side, that will try to move it forward. So in this case, we'll try to move thief pointer forward, right? So now thief pointer will move this at this particular location, and it is pointing to thief only. So now distance will be 1, and which is lesser than equals to k is true. So this police will catch this thief. This is a pair. Now we'll point the pointer to next, and this pointer, if you see, it is pointing to police, which is wrong. We'll move forward. Again, it is pointing to police, we'll move forward. This is pointing to police, move forward. So now if you see in this case, our T pointer is here, but P pointer is here. Okay. And now if you see the distance, that will be 5 minus 3, which is 2 lesser than equals to k is false. So if it is false, now P pointer is left side, so we will try to move P pointer next. So now distance again will be 1, and this police will catch this thief. So basically, even if you see through naked eyes, so distance was at most 1. So this police will be able to catch this thief, and this police will be able to catch this thief, but this police will not be able to catch any of the thief, neither this one, this one, this one. So basically, whenever I mean, police and thief are not in a range of k distance, so in that case, we'll try to move one pointer forwards. So I think you got what I'm trying to say. Let me try to code up here. So this was a brute force solution. Now let me try to optimal solution. So we will take pointer P, which is police, that is pointing to starting let's say 0, and we'll take pointer thief, which also be pointing to 0. Now let me take one n, basically size of the array, and while this P is less than n and T is less than n, basically both police and thief are in range of array. So we will take one while loop, and we will try if pointer P is lesser than or equals to n, which is basically trying to take the range, and we'll find if array of P is not equals to P, which means if it is a thief, so our pointer has to move forward, right? Police pointer has to point to the police only. So if it is not P, which means if it is T, or let me write this clearly, if they are equals to thief, so our pointer will be moving forward. In the same way, we'll have to point this T, which is thief pointer, to its correct position. So if they are equals to police, which means if our pointer is pointing to police, so in that case our thief pointer move forward, unless and until we find a correct thief only. So once we found the thief, we'll try to find if absolute value of like basically the distance is what mattering, like if police is left side or thief is right side or in the vice versa way, it doesn't matter. So that's why we are taking absolute value. If p and minus t, if this distance between police and thief is lesser than equals to k, which is asked in the question, so in that case our answer will be increased by 1. So let me take one count which will be counting how many thieves had been caught by police. And if let's say we have police and thief, I mean both are caught, police has caught the thief, so both the pointer have to move forward. Now if the distance is not the distance is greater than k, in that case we'll have to check which pointer is left side, which is right side. If t pointer, which is basically thief, if it is lesser than k, which means thief is lacking behind, so thief will increase by 1, else police will be increased by 1, and at the end we'll have to return number of thieves caught by the police. Let's try to run the code. It is giving wrong. Why it is giving wrong? I think here whenever let's say we don't have any police, so this p will go out of the range. So here somewhere it is getting, I mean if p is going out of the bound, then there is no need of counting the thief. So here we'll have to check if p is less than n and t is less than n. Let me try to compile. Yeah, it is running. Let me try to submit the code. Yeah, it got accepted. So basically it was that only, like if p is going out of the range, so in that case we don't have to count it, because we don't have any police basically to catch the thief. So even if in that case, like if it is, let's say p is n and t is having some value, which means police has ended, I mean police is not there. So and if it were satisfying, like basically absolute value is less than k, so in that case we were counting, which was giving us extra answer. So same with the thief also. So that is the reason we'll have to check these two things. So yeah, thank you guys for watching the video.